Right, hello again, Year 11. So I'm back. We're going to go through the Level 2 Paper 2 paper from June 2014. Okay, it's a calculator paper. Again, I'd recommend you had a go at this yourselves before kind of watching this video, and then just go through the ones you need to. So question 1, the graph of y equals f of x for the full domain is shown. The graph consists of a quadratic curve and a straight line. So we can see a quadratic here, and then a straight line here. Complete the boxes to describe f of x. So, you see it's saying f of x equals, so this is going to be some function between minus 2 and 2. So if we look where x is between minus 2 and 2, we've got to try and recognise what this function is. So hopefully you know that that's x squared. So that's just going to be x squared between minus 2 and 2. So the next one, they don't give us the function, and they don't give us the end of the domain either. So now we're looking at this line. So hopefully you can spot that's the line y equals 4. So this is going to be f of x equals 4. And we've got to say, so that's defined from between 2 and up to and including 5. So the answer there is going to be 5. Right, so on the mark scheme, x squared, 4 and 5, and it's just 1 mark for each. Right, question 2. The equation of line AB is y equals 12 minus 2x. The area of triangle OCA is 24 square units. Okay. And they want to know the coordinates of C. Right, so let's see what we can work out to start with from what they've given us. So maybe we can work out the coordinates of B, so I reckon that's going to be 0, 12. And to find the coordinates of A, this is where the line hits the x-axis, so that's where y equals 0. So that's going to be where 12 minus 2x equals 0. So 2x equals 12, so x is 6. Right, now let's think about this triangle, which is going to be, they've given it the area of 24. So to get that, they must have done half base times height. Now we know that the base is 6 because we found this x coordinate was 6. So the height must be, well, they've done half times 6 times the height and got 24. So in other words, 3 times the height is 24. So the height must be 8. So you need to spot then that the y coordinate of C must be 8. So then to find the x coordinate, we're going to have to sub back into y equals 12 minus 2x to find the x coordinate. So we know 8 equals 12 minus 2x. So 2x equals 4, so x equals 2. So just make sure you write down the actual answer at the end, which is 2, 8. Alright, so on the mark scheme, they've got a few different methods. So the first is they've found the x coordinate of A, like we did, 6, 0. They've done pretty much what we did here, so half times 6, we said height, they said y equals 24. So third mark for getting that the y coordinate is 8. Then subbing that 8 as y into that equation to get 2. Alright, good. Okay, so question 3. R, S and T are on the circumference of circle centre O. So 3A, 1 mark, give a reason why OTS equals x. So OTS is this here. So I would say that's because OS and OT are both radii of this circle. So this is nice. So OTS is an isosceles triangle. So that must have to be x as well. Let's just see what they say in the mark scheme. So lots of methods for question 2. So any valid reason from triangle OTS is isosceles, OT equals OS, or OT and OS are radii. Okay. Right, so now 3b, work out the value of x. So notice they haven't asked us for reasons, so we don't have to worry about saying this is because blah blah is isosceles and everything. So I think the most obvious way is to see we've got an angle at the centre here, and here we've got the angle at the circumference. So this angle must be double this angle. So in other words, 5x must be 2 lots of x plus 30. So 5x equals 2x plus 60. So 3x equals 60. X equals 20. Right, wonderful. So you get a method for some correct equation using that angle at the centre stuff. A mark for collecting terms and a mark for... So essentially 1 mark for setting up the equation, 2 marks for solving it. Okay, question 4. Expand x squared times by x minus 2. Pretty trivial. So x cubed minus 2x squared. Right, a curve has equation y equals x squared times x minus 2. Work out the gradient of the curve at the point 39. So part A is going to help us because we can't differentiate that in its current form. But we can differentiate it like this. So dy by dx will be 3x squared minus 4x. So this is going to help us tell us what the gradient is for any value of x. So if we want the gradient at the point 39, then we can sub 3 into this and it will tell us the gradient. So 3 times 3 squared minus 4 times 3. So that's going to be 27 minus 12, which is 15. So that's going to be the gradient. And part C, right, line L is the tangent to the curve at the point 39. So we've already worked out that dy by dx was 15 here. And they want us to work out the equation of L in the form y equals mx plus c. So because we already know the gradient, then we know y equals 15x plus c. So that's what the whole part B was doing for us. And then to find c, we can use the fact that when x equals 3, y is 9. So we can say 9 equals 15 times 3 plus c. So 9 equals 45 plus c. So c will be minus 36, I want to say. Right, let's check that, and I hope I haven't made any mistakes. So, part A, you get a mark for each of those, expanding it. You get a mark for 3x squared or minus 4x when you're differentiating, a mark for subbing in 3, and a mark for 15. And then for part C, you could use, we did it, y equals 15x plus c, and subbing in, you could have used the y minus y1 formula, which they've done there, and both of them lead to that equation. Right, so, question 5, solve this equation. So it looks a bit scary because it's full of fractions, so what I'd recommend doing first, some people like to kind of add these fractions together. What I would like to do is times across each of the 3 terms by something that's going to get rid of this 2 and this 5. So I'm going to times by 10. So now this is going to become, I'm going to put this step in the middle that you don't really need. You might be able to do this in your head. So because I'm timesing everything by 10, for the fractions just the numerator gets times by that. Right, so this 10 and the 2 cancel down to 5 lots of 4c plus 3. This becomes 2 lots of c minus 8 equals 10. So now it's on one line and should make it a bit easier. As I say, you can leave this line out. So we get 20c plus 15 plus 2c minus 16 equals 10. So 22c minus 1 equals 10. So 22c equals 11. Therefore, c equals 11 divided by 22, which is a half. So, 1 mark, so kind of doing what we did here. Correct equation with no unexpanded bracket. So if you expanded everything out, here you can see an example where they've done it adding together the fractions. Eliminating denominators correctly and collecting terms of their equations. That's what we did when we got 22c equals 11. And a final mark for a half, or 11 over 22. Alright. Question 6. 2 circles, each with centre O, are shown. So we've got x squared plus y squared equals 289, and x squared plus y squared equals 121. So work out the perimeter of the shaded section A, B, C, D. Right. So in other words, this area here. So we're going to have to work out all these 4 lines. So first of all, hopefully we recognise these. We can find the radii of these two circles. So OC will be the square root of 289, which I'm not sure on that one, is 17. So we can say this is 17. And the inside one will be the square root of 121, which I know that one, that's 11. So we know this length is going to be 6, and so is this one. And now we've got to work out these lengths. So we can see these are both quarter circles. So we can times the whole circumference. We can work out the whole circumference and then divide it by 4. So for this one, the whole circumference will be 2 pi r, so 2 pi times 11, and we've got to divide it by 4 because it's just a quarter of the circle. So that's 22 pi over 4, so 11 pi over 2, or 5.5 pi. I'm going to leave that as an exact answer at the moment, so I don't make any rounding errors. And similarly for the one on the outside, that's going to be 2 pi times 17 divided by 4, because it's a quarter of the circle, which is 17 over 2 pi. Right, so now I just need to add those all up. So 6 plus 5.5 pi plus 8.5 pi gives me 59.9. And that's, they haven't given us any units, so we don't have to put any units. And I'll just say that's the 3 significant figures. Okay, I could have written it as an exact answer, so that would have been 12 plus 14 pi. Let's see what the mark scheme says. So you get a mark for working out either of the radii. You get a mark for 17 pi over 2 or 11 pi over 2. A mark for getting the 6. A mark for adding them all up. And a mark for either get. So you're allowed anything between 55.96 up to 56.0. And then there's your exact answer, 12 plus 14 pi. So you can leave it as an exact answer. Right, question 7, simplify this. So first of all, so we want to give your answer in the form x to the power of something. So inside the square root we have to add the powers, so x to the 5 times x to the 9 is x to the 14. And then square root is the same as saying to the power of a half. So a half times 14 is 7, so that's x to the 7. Good. Right, 7b is a bit more difficult. So solve y to the minus 3 equals 125. There's two ways you can do this. I prefer to think, what do I put the power of y to? So it becomes just y to the power of 1. So in other words, what do we times minus 3 by to give 1? So that would be minus a third. And we've got to do the same thing to the other side. So that the left hand side becomes y, and then this is going to be 1 over, because it's a minus, and the third's going to make it the cube root of 125, so you get a fifth. The other way of doing it is thinking, well, y to the minus 3 is 1 over y cubed, so that means that 1 over 125 equals y cubed, so the cube root of 125 is a fifth. Sorry, that's really messy, but those are the two ways of doing it. Right, so you get a mark for a fifth here, and then if you messed it up a bit, here's where you can get one of your marks. Oh, I missed the first one. So that was just 2 marks for x to the 7, and you get 1 mark for your bit of working. Right, 8 looks like we've got vectors. Ooh. Right, m equals minus 2, minus 1, 3, 1. So show that m cubed is I, which is the identity matrix, which hopefully you know is 1, 0, 0, 1. So I reckon first of all let's work out m squared. So we've got to times together m twice. So the first entry is going to be minus 2 times minus 2, which is 4. Plus minus 1 times 3, so we've got to take away 3, so that's going to be 1. This top right entry is going to be minus 2 times minus 1, which is 2, plus minus 1 times minus 1, which is minus 1. So that's going to be 1. The bottom left, by the way, the way to remember this, if you're thinking work out the bottom left, that means you're using the bottom row and the left column. So 3 times minus 2 is minus 6, plus 1 times 3 is 3. So minus 6 plus 3 is minus 3. Finally, the bottom right, so I'm going to use the bottom row and the right column. So 3 times minus 1 is minus 3, plus 1 times 1, so that makes minus 2. Feel free to do some like working at the same time, because this can be quite difficult. And then we need to take m squared and times it by m to give m cubed. So I'm going to take my m squared, which was 1, 1, minus 3, minus 2, and times it again by m. So top left is going to be 1 times minus 2, which is minus 2, plus 1 times 3. So minus 2 plus 3 is 1. So that checks out, so remember we want this to be 1, 0, 0, 1. Then the top right is going to be 1 times minus 1 plus 1 times 1, which is 0. Good. Then the bottom left is going to be minus 3 times minus 2, which is 6, plus minus 2 times 3, which is minus 6, so we get 0. Finally, the bottom right is going to be minus 3 times minus 1, which is 3, plus minus 2 times 1, which is 1. Good. So that equals I. So mark scheme, they give you 2 marks for, it looks like that's for finding m squared. Yeah, which is what we got. So 2 marks for doing that first multiplication. You get a mark for then multiplying that by m, and you can do it in either order, it'll still work, and a mark for arriving at 1001. Right, question 9. Right, AB is parallel to CD. Is EF parallel to CD? AB is parallel, so we know this top line is parallel with the middle line. They're asking us, is the bottom line parallel with this line? So we don't know if it is or not. So I reckon the way to think about that is, well, if they are parallel, this angle and this angle will have to add up to 180 degrees because there'd be supplementary angles. If they don't, then they're not parallel. So because we know these two are parallel, then we know this and this must add up to 180. So that angle ACD will be 102 degrees. So now using angles around a point, we can do 360 minus 102 minus 115, and we get the angle below is 143. So if we do 143 plus 32, that gives us 175. So they're not parallel because this does not equal 180. So let's see what they want. So I think that takes a bit of explanation in the mark scheme. So first of all, you get a mark for finding angle ACD, a mark for finding angle ECD, so that's 2 out of the 3 marks, a mark for adding them up, and you need to conclude it. So this equals 175, and you need to say no, or saying that doesn't equal 180, so you need to actually answer the question and say no. Okay. Right, question 10. So more matrices. So the unit square OABC has vertices blah 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 blah. OABC is mapped to OA-B-C- under transformation matrix M. Work out the matrix M. Okay, now if you've done a lot of matrices, you might have spotted this is a enlargement scale factor -1. So some of you might already be able to just write down that's -1, 0, 0, -1, and I put some explanation, but you're not expected to know that. Right, so the way of doing this without knowing is to think about, now you have to just remember this, that where does this take the vectors, or coordinates 1, 0 and 0, 1. So you can think of these as the identity matrix, which is 1, 0, 0, 1, split in half. So this is the first one, this is the second one. So let's think about where it does take them. So 1, 0, so that's this coordinate here. Where has that gone? Well, A has gone to -1, 0. So the x coordinate is -1, the y coordinate is 0. And then let's think about where 0, 1 has gone. So 0, 1 is this point here, and that's gone to 0, minus 1. Okay, so all you have to do is mash these together. So put this one on the left and this one on the right, and by magic that gives you the matrix. So just remember, this is kind of a foolproof way of doing it, but it's not very. I don't really like it because you don't really understand what's going on. So just think about, where does 1, 0 go, where does 0, 1 go, and put them together in one matrix. So it's anything where you're transforming a unit square, that's what you do. So looking at the mark scheme, you just get 2 marks getting the answer. So you don't even have to write down it's a rotation 180 degrees or an enlargement scale factor -1 or reflection in y equals minus x. Right, good. 10b, OABC is mapped onto O double dash B double dash C double dash under transformation matrix -3, 0, 0, -3. Draw and label OA blah 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 blah. So you might already know that's an enlargement scale factor -3, but if you don't, let's go through how you do it. So O will always stay where it is, and now what I'm going to do is transform each coordinate by the matrix. So the first one, let's see where point A ends up. So we're going to have to multiply it. So the point A is 1, 0. So if we multiply that out, -3 times 1 is -3, 0 times 0 is 0. So the x coordinate will be -3. 0 times 1 is nothing, -3 times 0 is nothing. So 1, 0 has been mapped to -3, 0. So let's write it there and label it A dash dash. And then I'm going to do the same things for B and C. So B is the point 1, 1. -3 times 1 is -3, 0 times 1 is 0, so that goes to -3. 0 times 1 is nothing, -3 times 1 is -3. So B has gone to -3, -3. There it is. And finally C, -3, 0, 0, -3. And we're timesing that. This is 0, 1 this time. Goes to -3 times 0 is nothing, 0 times 1 is nothing. 0 times 0 is nothing, -3 times 1 is -3. So that's gone to 0, -3. So then we can draw it on our diagram. And there we go. So in the mark scheme, correct square, vertices A dash dash -3, B dash dash blah blah blah, with correct labelling. So it has to have labelling. Right, 14, simplify fully this. So the first thing I'm going to do, because it's a divide, I'm going to flip the second fraction and make it a multiply. And then we can think about if anything's going to cancel out. Okay, so because this is c to the 7 and this is c squared, the 7 will cancel down to a 5 and these c squareds will disappear. We can cancel down this 5 and this 15 to a 1 and a 3. The 8 and the 6 we can cancel down as well to a 4 and a 3, so we're dividing by 2. And the d's, we can cancel these d cubes completely, and that 6 is going to become a 3. So that's really messy at the moment, so let's tidy it up. So we've got 4c to the 5 on top over 3d cubed times 3, which is 9d cubed. So I don't think we can simplify it any further than that. And that's what they want in the mark scheme. So 3 marks for any of those. Alright. 11b, so we've got to write this as a fraction in its simplest form. So we're going to have to make both the denominators the same, just like we do when we're multiplying together numerical fractions. So let's make them both m plus 1, m minus 4. And then we've just got to make sure we times the numerators by whatever we've times the denominators by. So this one's been times by m minus 4. This one's been times by m plus 1. So now we just need to multiply out and simplify the numerators. So we've got 5m minus 20 plus 6m plus 6 all over m plus 1, m minus 4. And that's going to equal 11m minus 14 over m plus 1, m minus 4. And just double check you can't cancel that down. So it might be sometimes you could factorise this and then cancel out one of these, but in this case we can't. So you get a mark for seeing this as a common denominator, a mark for getting the numerators right, a mark for multiplying them out and kind of adding them together, and a final mark for this, or you might have multiplied this out, that's fine, but you don't need to. Right, question 12. The circle x squared plus y squared equals 20 and the line y equals 2x intersect at the points D and E. Work out the coordinates D and E, do not use trial and improvement. So, essentially, if we want to know where two equations intersect, that means we've got to solve them simultaneously. So we don't even really need to worry about the actual graph. We can just think, right, we're solving for what x and y values are these two things the same. So x squared plus y squared equals 20 and y equals 2x. Yeah. Okay, so when you've got one of these which is a quadratic, I'd always use substitution. So if wherever we see a y, we're going to write 2x. So we get x squared plus 2x squared. 2x squared equals 20. So very important those brackets are in the right place because we're squaring 2x. So 2x squared is 4x squared. So in total we've got 5x squared equals 20. So x squared equals 4. So x will equal 2 or minus 2. Okay, so you see we've got 2x results because we've got two coordinates D and E. So to get the y coordinates we just have to sub these in. So if x is 2, y must be 4 because it's 2 times that. And if x is minus 2, y would be minus 4. So we can see 2, 4 is going to be D because that's in the kind of top right quadrant, and this is going to be E. And they give you a little space to write it in, so make sure you put them in the right place. So you might lose a mark if you get them the wrong way round. So a mark for subbing in, a mark for getting 5x squared equals 20, and essentially solving to get x equals 2 or minus 2, and then a final answer for getting these in the right place. Okay. Here are 5 graphs, A, B, C, D and E. For each of the following statements, decide which graph is being described. Right, for 13a, the rate of change of y with respect to x is always negative. So this means this is just another way of saying the gradient. So for which of these graphs is the gradient always negative? So for A, we can see the graph's positive. For B, it doesn't really have a gradient because it's vertical. C, we can see it's always negative. D, it's always 0. And E, it's always going upwards. So the answer for A will be C. 13b, the rate of change of y with respect to x is always 0. So you can think of this as the gradient is always 0. So that's going to be this horizontal line because y never changes no matter how x changes. 13c, as x increases, the rate of change of y with respect to x decreases. So you can think of this as we run from left to right, so as x increases, the gradient decreases. So as we move from left to right, we've got to look for one where the gradient is going down. Whereas here, as we move from left to right, we can see the gradient's going up, if I imagine drawing tangents on that. On C, the gradient's never changing, nor is it on D. On B, it doesn't exist. So we could say it's A by process of elimination. But if we imagine on A moving from left to right, if you think what's going on with the gradient, you can see the gradient is slowly becoming shallower, so it's decreasing. So for that one, it will be A. Okay, 14. Rearrange this to make W the subject. This is a really standard rearrangement question. So we times by the denominator. Process is always the same when you've got them like this. Multiply out the left. get all the terms with a W on one side. So I think I'm going to put them on the right. You could put them on the left, it will make no difference. But if I put them on the right, they'll both be positive, which is nice. So I'll have 2W plus 3XW. And on the left, 5x minus 1. So I've moved the 1 over. Then factorise out what you're trying to make the subject. So W, that was going to become 2 plus 3x equals 5x minus 1. And then divide by 2 plus 3x. So finally we'll have 5x minus 1 over 2 plus 3x. Okay, so in the mark scheme, got to go through all these. So 1 mark for timesing by that, 1 mark for multiplying out, 1 mark for getting all the W stuff on one side, and then factorising and dividing. So again, you could have this, which is if you got everything on the left. Okay. Right, 15a. The nth term of a sequence is n squared plus 12n plus 7. By factorising or otherwise, show that the 20th term can be written as a product of two prime numbers. Right, when they say or otherwise, I wouldn't do or otherwise because they're trying to help you. So let's try and factorise. We want two numbers that multiply together to give 27 and add up to give 12. So I reckon that's 9 and 3. Right, so the 20th term is going to be when n is 20. So if we sub that in, that's going to be 20 plus 3, which is 23, times by 20 plus 9, which is 29. So we've shown the 20th term is 23 times 29. Okay, good. Which is easier than getting, what would the answer be? It would be easier than getting 667 and trying to think, oh, which prime number divides 667? Right, 15b. The nth term of a different sequence is n squared minus 6n plus 14. By completing the square, here's that scary word or otherwise again, show every term is positive. Right, so let's complete the square. So first of all, we'll have n minus 3 all squared. That's going to give us n squared minus 6n plus 9. So I'm going to take away 9. So this bit now all equals n squared minus 6n plus 14. So we get n minus 3 squared minus 9 plus 14 is 5. So there's a couple of ways you can explain this. You can imagine the graph of this is going to be a smiley quadratic, so like a U shape, and its minimum point is going to be 3, 5. So it's going to look something like this. You could do a nice sketch for the examiner and do a little explanation. Or you could say this is something squared, so the smallest this could be is 0. And then if you add 5 to it, it's going to be positive. So let's have a look at the mark scheme. So you just get 15a, 29 and 23. 15b, so they've completed the square, that gets you 2 marks. And then something here, you can say anything to the words of this is always positive, so adding 5 is always positive. Or states the minimum value is 5, or states 3, 5 as a minimum point. So you don't even need to draw them a nice graph. Alright. So lots of different ways of doing it, which are a bit more scary. Right, 16, simplify a minus 2 squared over a minus 2. So if you're dividing something squared by itself, you're just going to be left by itself. So you can imagine we're cancelling out one of the a minus 2's. Alright, here is a sketch of x minus 2 squared. The curve touches the axis at B and intersects the y-axis at C. Angle ABC is 90 degrees. The curve passes through A, which they've called a minus 2 squared. Work out the value of A. Right, I think this is the first really seriously difficult question we've arrived at. So let's try and work out what we know. So they're all points on the curve. So I reckon we can find C because we know the x coordinate is 0. The y coordinate is going to be, well, if we sub in x is 0, we'll get 4. Right, B is the point 2, 0. And we know it's at 90 degrees to this. So I'm thinking, well, we can work out the gradient of this line. And because that's 90 degrees, we can then work out the gradient of this line. And then hopefully that'll help us find A. So The gradient of this time, we've gone along 2 and down 4, so the gradient's minus 2. So this line must have a gradient of a half. Alright. So I think we've got enough information to work out the equation of line AB. So we know y equals a half x plus c, and then we just need to sub in 2, 0. So in other words, when y is 0, x will be 2. So 0 equals 1 plus c, so c is minus 1. So we can see the equation of AB is y equals a half x minus 1. Obviously you'll write this out much more neatly than I am, in order. Okay, so let's get rid of that working. Now let's think, what is the point A? A is the point where our line AB intersects y equals x minus 2 all squared. So in other words, that's going to happen when this equals this. So we can solve this equation and then decide which one is A. So, if we expand the right, we'll have x squared minus 4x plus 4. Now I'm going to times everything by 2 because I don't like this half x. So that's going to become x minus 2 equals 2x squared minus 8x plus 8. So we'll have 0 equals, again, I'm squashing this into a really tight space, but you can do it a lot more neatly than me. So 0 equals 2x squared minus 9x plus 10. Alright, so can we factorise that? Well, I reckon 2 must be a solution because we know that's there. So I reckon this will be 2x minus 5. Let's just see if that works out. So 2x squared minus 5x minus 4x, that gives us minus 9x plus 10. So the two solutions are x equals 2, which I knew because I knew our line hit when x equaled 2, or 2.5. So one of those is A. Now we know when x equals 2, that must be the point B. So A must be the point where x is 2.5. So in other words, A is 2.5. So let's have a look at the mark scheme, which I imagine is going to be very complicated, lots of alternative methods. So a mark for finding C, a mark for finding the gradient, a mark for, they've done it slightly differently to us. So they've found the gradient between this theoretical point A and B, and then they know it must be a half. So they've got 2.5. And then our way is the second one. So a mark for finding C, a mark for minus 2, a mark for getting to a half x minus 1, a mark for setting them equal to each other, and a mark for solving to get 2.5. So maybe their way was actually a bit easier. Right, on to 17a. Factorise fully 12c squared d minus 9d squared. So I reckon we can factorise out of 3 and also d. So the first one's going to be 4c squared, and the next one's going to be minus 3d. Right, good. Factorise fully, blah, 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 blah. Now, you might be tempted to expand all this out, but it's actually going to make your life much more difficult because you'll end up with a cubic. If you look, this is w plus 4 cubed, and here we've got w plus 4 squared. So we can factorise out a w plus 4 squared, and then think, well, what would go in our brackets? Well, what do we times w plus 4 squared by to get w plus 4 cubed? We'd have to times it by w plus 4. And then what do we times w plus 4 squared by to give w4 squared times w plus 1? Well, that would be just w plus 1. So all we have to do is simplify what we've got here. So we've got w plus 4 all squared, and then in the brackets we've got w plus 4 minus w plus 1, which will be 3. So the answer is 3 lots of w plus 4 squared. Right, so the mark scheme says 17, so 2 marks for the first one. 1 mark for spotting w plus 4 all squared as a factor, 1 mark for kind of factorising it, and a mark for the final answer. and they show you there the amount of work you'd go through if you had to properly factorise it using quadratics and stuff, which doesn't look that much fun. Right, 18, A, B, C, D, E, F, G, H is a cuboid. Work out the angle between EC and ABCD. So here's EC as a diagonal line, and ABCD is going to be that. So we're looking at this triangle here, ACE. Remember when you're finding an angle between a line and a plane, it's always got to involve a right angle somewhere. Okay, so if we think about ACE, we're going to have to first of all work out the line AC, and then that'll be enough information to work out this angle. So this we can work out using the fact we know ABC is right angled, and we can just use Pythagoras. So the square root of 8 squared plus 14 squared, which is 2 root 65 as an exact answer, but you might want to think of it as root 260 for your working, so they're the same thing. And it's nice to write it as an exact answer. So then to work out the angle C, if we think, if we draw out the triangle ECA, we know that's a right angle. We're trying to find this, let's call it X. This is root 260, or 2 root 65, and this is 7. So this is the opposite, this is the adjacent. So tan X is 7 over root 260. So X, I'm going to do inverse tan of 7 over root 260. And that gives me the wrong answer because I'm in radians. So let me just sort my calculator out. So that gives me 23.5 degrees. Alright, so again, going to the mark scheme. A mark for root 260, a mark for tan X is 7 over that, and a mark for your final answer. Question 19. On this diagram, all lengths are given in centimetres. A cylinder and cone are joined together to make a solid. The cylinder has radius r and height r plus 5. A cone has radius r and slant height 9r minus over 2. Remember, you always get all the formulae at the start of the paper. So, part A, show the total surface area of the solid in centimetres squared is pi r over 2 times by 3r plus 4. So let's think about all the different faces. I think there's going to be 3. There's going to be the kind of face of the cone, the slope face, this face on the cylinder that's kind of a rectangle, and the bottom, which is a circle. So for the formula for the surface area of a cone is pi RL. So in this case, R is R, that's fine, and L is 9R over 2. So in total, we've got 9 pi r squared over 2. Okay. Then this cylinder, remember this is going to be a rectangle if we imagine unwrapping it. So it's got a height of r plus 5, and the circumference, which is going to kind of be like the base of the cylinder, is 2 pi r. So that's going to be 2 pi r times by r plus 5. And finally, the base, the kind of circle face, is just going to be pi r squared. Alright, so we need to add all those together and make sure we get something like they've got. So we're adding together 9 pi r squared over 2, 2 pi r times r plus 5, and pi r squared. Alright, so let me get rid of all this. So what are we aiming for? We're aiming for 5 pi r over 2, 3r plus 4. So I'm going to try and times some of this out. So we've got 9 pi r squared over 2 plus 2 pi r squared plus 10 pi r plus pi r squared. And then, can you see we've got lots of pi r squared? So let's try and bring those together. So we've got 9 over 2 pi r squared. We've got another 2 pi r squared, and then we've got a final pi r squared on the end. So in total, that's 15 over 2, or 7.5 pi r squareds, plus 10 pi r. Right, now it looks like what they've done is factorised out 5 pi r over 2. So let's just do that and make sure it checks out. So 5 pi r, and then here we'd have to have, 5 pi r over 2. Is that what I just said? Yeah, that's what they factorised out. So we'd have to times that by 3r to get the first term, and 4 to get the last term. So I think the difficult bit there is really all the algebra afterwards. So you get a mark for, that's the area of the rectangle, this is the sloped surface, a mark kind of adding everything together, and a mark for kind of factorising to get to the answer. They want to see a bit of work because they've given you the answer. Right, so 19b, the total surface area of the solid is 1200 pi centimetres squared. Work out the value of r. So we've got to set our 5 pi r over 2, 5 pi r over 2, 3r plus 4 equal to 1200 pi. So I don't like this kind of 5 pi over 2. So first of all, we can straight away cancel out these pi's. And then we can imagine if we times by 2 and divide by 5 to make the left equal that. Or you could even think of it as dividing by 5 over 2. So I'm going to do 1200 divided by 2.5, and that gives me 480. So that looks a bit friendlier now. So we'll have 3r squared plus 4r minus 480 equals 0. So I've expanded it out and brought the 480 over. And now we can see we've got a quadratic we need to try and factorise. Now, I think that looks really horrible to factorise. Some people are really good at it, I'm not. So I'm just going to put it into the quadratic formula. So minus b plus or minus b squared minus 4 times a times c all over 2a, so all over 6. Right, so that gives me two answers. So either r equals 12 or minus 40 over 3. Now, because we know it's a positive because it's a radius, we know it can't be negative, so it's okay just to say r equals 12. So let's have a look at the marks. You get a mark for setting it equal to 1200 pi, a mark for arriving at some quadratic with everything on one side pretty much. You get a mark for attempting to factorise the 3-term quadratic or attempt to substitute into the formula, so you can see it can factorise. Yeah, and then a mark for correct substitution in the formula, and a final mark for getting 12. Do not award if negative solutions included, so you need to make sure you do that. Well, you don't do that even. Right, 20. The diagram shows a right-angled triangle. Prove algebraically that x to y equals 2 to 3. So in other words, x and y are in the ratio 2 to 3. Right, this is a bit of a weird question. I'm assuming because it's a right-angled triangle, we're going to do some Pythagoras-y stuff to it. So let's see what happens if we make that. So we've got to come up with some formula connecting x and y. And if we think about what this means, well, that's equivalent to saying x over y equals 2 over 3. So maybe if we expand all this, we'll get to that. Right, I'm going to move down. And sorry, I'll continue up here. Apologies again for the mess. So 36x squared plus, so these brackets will become x squared plus 2xy plus y squared. And that's going to equal 64x squared minus 8xy minus 8xy, so minus 16xy plus y squared. First of all, let's quickly get rid of these y squareds from each side. And then I'm going to move everything over to the left, I reckon. So I think that'll look nicer. So we'll have 64 minus 36 is 28x squared. Oh, we've also got this one here. So we need to take that away as well. So sorry, that'll be 27x squared. And then we'll have minus 18xy. And there's no y squared, so that equals 0 really. So remember, I think I just wanted to get everything on one side because that always seems like the right thing to do when we see an x squared. But that doesn't really help as much. We want to show that kind of x over y equals 2 over 3, or there or thereabouts. So let's move the 18xy back over. So we'll have 27x squared equals 18xy. Now, if we divide by, we can cancel down 27 and 18 so we divide them both by 3, we get, or even by 9, we get 3x squared equals 2xy. Then if we divide by x, we get 3x equals 2y, which if we rearrange that, we can say x over y equals 2 over 3. Therefore, x to y equals 2 to 3. Right, so that was very difficult. So we had to kind of use Pythagoras, expand it all out, which was a lot of work in itself, and then think about what we... I think the hardest bit was realising you had to arrive at something like this. Okay, so getting to there, I think, is really the end point. So you get marks for setting up the equation. You get a mark for expanding the right. Sorry, you get a mark, mark for expanding your c squared. A mark for expanding x plus y squared. So you've already get 3 marks for the start bit. A mark for kind of getting it all on one side or having it equal to each other. A mark for factorising and dividing, which is what we did. Okay, e.g. 27x equals 18y. And a mark for any of these, which proves it. So we got to this and then said this. So either's fine. Right, final question. Solve 16 sine squared x equals 1 between 0 and 270 degrees. So if you think of, imagine this is like 16x squared equals 1. We've got to solve that in the same way and then solve the quadratic. So we'd start off getting x on its own, so we'd say x squared, but in this case sine x squared equals a 16th. And then we'd square root. So if we were doing this one, we'd say x squared equals a 16th. And then we'd square root and say, but when we're square rooting, we need to make sure we're doing plus or minus. So x would be plus or minus a quarter. So in this case, sine x would also be plus or minus a quarter. So we've got 2 equations to solve. Sine x equals a quarter, or sine x equals minus a quarter. We've got to solve it between 0 and 270. So let's draw our sine curve, which we need to do whenever we're solving trig equations. So we know it looks like this. Between 1 and minus 1, that's 180, that's 360. We know it carries on backwards and forwards as well. So I'm going to do inverse sine of a quarter, gives me 14.5 degrees. So one solution would be 14.5 degrees. And then we can get, if we look at that, we can see we've gone in 14.5 from 0. So to get the other solution at the same height, we're going to have to go in 14.5 from 180. So I'm going to do 180 minus answer, which gives me 166 degrees to 3 significant figures. Okay, so we've got 2 solutions for that first one. Then for the second one, I'm going to do inverse sine of minus a quarter. And that gives me minus 14.5 degrees. So actually they've given us an answer that is not in our range of solutions, but we still need to use it. So they've given us an answer here, and we want to find these 2. Right, so we can see we've gone in 14.5 from 0. So for this one, we're going to have to add on 14.5 to 180. So I'll do 14.5 plus 180. Probably didn't need a calculator. It was 194.5 degrees. So to 3 significant figures, I'm just going to call it 195 degrees. Remember not to include this in your final solutions because it's not in our range. And then this one is going to be 360 minus the 14.5, which gives me 345.5. But actually, be careful. Our range here, where we want the solutions, is 0 to 270. So that 345.5 isn't in that range. So your three solutions are 14.5, 166 and 195, which you can sum up nicely at the end. Okay, so you get a mark for square rooting and a mark for 14.5, a mark for having minus a quarter and getting minus 14.5 or 180 plus that, a mark for anything between 194 blah blah blah, so between these two values, and a mark for anything between these two values. So you get 3 of the marks for just doing the kind of first steps without having to play around with the sine curve, and the last 2 marks are for finding the extra solutions. Okay, right, so on to the last question of the paper. Alright, so the curve f of x equals has differential equation kx x minus 3 cubed, where k is a negative constant. There is a stationary point at x equals 3. Determine the nature of this stationary point. You must show your working. Right, so we know that this is when this equals 0. Now you've got 2 options on working out the nature of the stationary point. You can either find the second derivative, or you can sub in points either side and work out if they're positive or negative. Now because this is quite a complex equation, we'd have to expand out quite a lot to find the second derivative. I'd recommend subbing in points either side to work it out. So what I think we should do is say work out dy dx when x is 2 and when x is 4. So we know when x is 3 that it's 0, it's a flat line, a horizontal line. So if we sub in 2, dy by dx will be k times 2 times 2 minus 3 squared. So that's k times 2 times minus 1 squared is 1, so it equals 2k. Now is this positive or negative? Well, they've told us k is a negative constant, so we know that at x equals 2, we don't know what the gradient is, but we know it will be negative. Okay, so it looks like it could be a minimum point, it might be a point of inflection, depending on what happens here. So if I sub in 4, we've got k times 4 minus 3 cubed. Just realised I made a mistake here, so I put squared here. That should be cubed, which changes it drastically because this becomes a minus, this becomes a minus, so this will actually be positive. So minus 2 times a negative number will be positive. Okay, on the other side we've got k times 4 times 1 cubed, which is 1, so we get 4k. So now this is 4 times a negative number, so will be negative. So we can imagine our curve, it's got a positive gradient, a stationary point, and then a negative gradient, so it's a maximum. Okay, now what do the examiners want to see? They want to see substitutes a value between 0 and 3, which is what we did, we used 2, and obtains a correct expression in k. So here's where I almost made my mistake, where we should have got minus 2k. Obtains a correct expression for both and correctly indicates whether they are positive or negative. So minus 2k, which we got, and 4k, which we got, and then we decided it was a maximum point. So you can see you can do the second derivative, but it's quite difficult. You have to do a lot of expanding. But then you get 18k, which is negative, therefore it's a maximum. Okay, again, hope you found that useful. Let me know if you've got any requests or anything, and I'll see what I can do. Thanks a lot.